Hello, welcome again. We are solving some questions of machine design. The topic is ball, shaft, rolling and sliding contact bearing. Question number 22 is a general bearing has a shaft diameter of 40 mm and length of 40 mm. The shaft is rotating at 20 radians per second and the viscosity of lubricant is 20 millipascal second. The clearance is 0.020 mm. The loss of torque due to viscosity of lubricant is approximately option A 0.04 Newton meter, option B 0.252 Newton meter, option C 0.4 Newton meter and option D 0.652 Newton meter. So this is now, so this is your general and this is bearing. General is small r and radius of bearing is capital R. So the maximum difference between the general and bearing is r minus r, or it is radius is it. Okay. General is rotating and bearing is fixed. So the fluid or oil layer adjacent to general is moving with the same speed as that of general, and fluid adjacent to the bearing uh, is stationary. So there is difference between the speed of the two layers of general and bearing, which are adjacent to general and bearing. Okay. So from this, as this general has a speed of n revolution per minute or per second, so we can find out the speed of general. So that speed of general will be same. That speed will provide a velocity to the oil, which is adjacent to the this general. Okay. So now finding out this velocity and using Newtonian's law, because difference of velocity here is speed of general, and difference of distance is or distance between them is your r minus r. So now using Newton's law is tau is equal to mu du by dy, and du is your velocity of general, that is pi dn. So pi is d is your diameter of general, and n is revolution per second, that is 20, and this is 40. Or diameter general and bearing we can take same because of this because it will make a negligible difference. Okay, so that's why we have taken d here, or we can say it will be 40.02 or 40.04. That will make no difference, so we can take 40. Okay. Now dy is your distance between the general and bearing, or radius is your 0.02 mm. Okay. So dy is your 0.029. So putting these values of du and dy, and viscosity of the lubricant is given as 20 millipascal second. So it is 20 Newton over minus 3. Okay. So putting these values, we have a shear stress. Putting tau is equal to mu is equal to 20 Newton over minus 3, and that is 800 pi, and dy is your 0.02. So shear stress is 2511.274 Newton per meter square. Okay. So shear stress or Newtonian stress between shaft and between general and bearing is this. Okay. And the length of the general is given, length of the bearing or general is given as 40 mm, and diameter is given 40 mm. So area for that shear stress will be pi d into s, or pi into 0.04 into 0.04, and this is the shear stress. So tangential force will be your tau into area. So that is your 12.623 Newton. So tangential force is 12.623 Newton. Okay. So this is your tangential force, and if we multiply by radius of general, okay, or radius of bearing, then it will give a torque loss, because these are approximately same. So as the diameter of general or bearing is given 40 mm, or it will be radius will be 0.02 meter. So that is in meter and it is in Newton. So torque loss will be a 0.252 Newton meter. So that is force into radius. Radius is 20 mm or 0.02 meter and tangential force is 12.623 newton. So answer is option B.